Now we're reviewing Chapter 9, and I decided to make it just by itself. And that's because there's so much to cover. In Chapter 9, we started with the Pythagorean theorem. Everybody did very well on this one. It's our standard that we have a triangle with C being the hypotenuse and A and B being the legs. So it's A squared plus B squared equals C squared. Only for right triangles. And then we progressed to special angles. Now this made it very exciting because all of a sudden we're opening the door for trig. Trig, we understand ratios are constructed. But right here, we're first learning about a 45, 45, 90-degree triangle. In a 45, 45, 90-degree triangle, the hypotenuse is n square roots of 2, whereas the legs are all the same number. So this is an easy way of finding exact values. Very little math and works really nice. Well, then we went to the other one, and this is the 30, 60, 90. And this one says the smallest side, the one opposite the 30 degrees, is a size of n because it's a shorter side. The larger side is opposite 60 degrees, n square roots of 3. And the hypotenuse is twice that n value. So again, exact values and makes life easier. In the course of our study, we learned about SO, which is sine is opposite side over hypotenuse. Ca is cosine adjacent side over hypotenuse. And TOA is tangent. Those are the three basic functions of a trig. And it is tangent is opposite side over adjacent side. So SOHCAHTOA is a mnemonic for structure of trig functions. All right, so here we go. So we're going to do some examples now. And our first one is Pythagorean theorem. Because we don't have any further information, we have two sides, and the side opposite the 90-degree notation is the hypotenuse. So here we're using a squared plus the b squared equals some c squared. In this case, we have 20 squared plus 21 squared equal to c squared. When we do the math, and I think I have my calculator. No, I don't. Let's put up my calculator. Here it comes. and it's there. Good. All right, so I'm going to place it right there so I can do some math with you and make sure that I have some accuracy involved. Now, I want everybody to be punching keys. This is your future. Squared plus the 21 squared gives me 41. And we're going to take the square root. So we find what the hypotenuse is. I get 29. So this is known as a triple, but that's not important for us now. We just wanted the value. All right. So let's look at this one. This is special triangles. How do I know it? Well, it's a right triangle, and one of them is 60, so the other one is 30. So they want the values of x and y. Y is down here. All right. So we're going to write our structure. 30, 60, 90. We know this is n, and square roots of 3, and 2n. Well, we're given the opposite of 30, so n is 8 square roots of 3. Okay. So then we would make the 60 side, the y. Oh, well, let's do the x. X is a hypotenuse. So it would be twice the 8 square roots of 3, which make it 16 square roots of 3. Now we need, so this is my x. Now we need the y, and the y is here. So we know that n square roots of 3 equals 8 square roots of 3 times the square root of 3, because this is n. All right. So, well, the square root of 3 times the square root of 3 is 3. So it's 8 times 3, 24, is y. So x is 16 square roots of 3, and y is 24. Now, they're wanting us to use what we know about area and perimeter of a triangle. Area is the sum of the sides. Perimeter. Area of a triangle is 1/2 base times height. So this is an interesting problem because we have a 60-30 special angle and we have a 45-45 special angle. Let's start with the 45-45 because we have some values given to us. All right, we know it's n square roots of 2. Well, this is a hypotenuse, so I have 3 square roots of 2. Therefore, n is 3. That's the shorter side, each of the sides, rather. So this is 3, and this is 3. All right, so I've got the 45-45. Now I've got the 60. Now 30 is n. This is n, and square roots of 3, and 2n. N is 3. Therefore, 60, opposite of 60, is 3 square roots of 3. Twice n is 6, the hypotenuse. All right. So now let's talk about doing the math. Perimeter is going to be the 3 square roots of 2 plus the 6 plus the sum of these two numbers. 3 plus 3 square roots of 3. So my perimeter is going to be 6 and 3 is 9 plus 3 square roots of 2 plus 3 square roots of 3. and this is in units. Now, this is exact, but we really just need a more or less. So let's look at that. We're going to enter what we see. Sorry about that. We're going to have our 9 plus 3, oops, sorry, roots of, oops, I forgot my 3. No, yes, 3 square roots of 2. Back up there. Let me erase it. Let me do it again. 9 plus square roots of 2 plus 3 square roots of 3. Oops, there I made a mistake. Isn't that normal, right? Let me clear it again. Forgot to move it out so it gets out of the parentheses. Plus 3 square roots of 2 plus 3 square roots of 3 and enter. And I have approximately 18 4/10 units. Right. Now we're going to do area. Well, area is half base times height. So I've got half, and our base is 3 plus 3 square roots of 3, and our height is 3. So we're going to enter that in our calculator. And I'm going to get approximately 12.3 square units. All right now. So I got that part done. Now we're talking about a tangent. And we're supposed to write it as a fraction and as a decimal. Right. Well, tangents of some angle is, and we're talking acutes, is opposite over adjacent. Or the angles of the measure of angle M and angle N. These are the acute angles, less than 90 degrees. So let's make the tan of angle M. Opposite is 6 over adjacent is 8. I would reduce it to 3/4. All right, so this is my fraction. I would divide it out and get 75 hundredths. And this is my decimal. Now I'm going to do the tangent of angle N. To do angle N, I'm doing opposite over adjacent. So angle N is going to be 8 over 6. We notice it's the flip of the first one that we did. As I reduce it, I'm going to have 4/3. When I make a decimal, I'm going to have a repeating decimal. All right. Oh, 1 and 1. Sorry about that. I apologize. This is my fraction, my decimal. All right. So now we're in the swing of things, and now we can start working on other aspects of learning the trig scenarios. So what we want here is the sine of angle X and the cosine of angle X, as well as the sine of angle Z and of angle Z. So we can study the relationships of them. So let's start with angle X. Sine is opposite. Now this is the hypotenuse. 7 over the square root of 149. All right, because that's opposite over adjacent. Hypotenuse. And cosine is adjacent over hypotenuse. So that would be 10 over the square root of 149. So now we're coming back to the sine of Z. Well, Z is over here. Opposite for it is 10 over the square root of 149. And if I did the cosine, I would have 7 over the hypotenuse. And we can see the relationship of reciprocal values of the numerator anyway. Exchanging values, I should say. Now they want to find the tangent of the acute angles. Again, the same thing we did before, as a fraction and a decimal. So we're going to do a little bit math here. So, oh, is that a repeat? It sure is. That's a duplicate. I'm sorry. So I'll continue on. We want to find the value of X using trig functions. All right, I'm ready. I know you are too. So I have an angle given, and they only want X. Well, I don't have a hypotenuse, but I have, this is opposite over adjacent. So this is a tan of 38 equals the ratio, it's a fraction, of 10 over X. I'm going to multiply by X. And then I'm going to divide by 10 of 38. This will give me what X is. Right, so let me put this over here on this side. And I'm going to enter what I see. 10 divided by 10 sorry about that, of 38. And we're going to do 1 decimal. That many units. Right. Now this is interesting because it shows the relationship of coexistence, which we proved over here. In other words, when we did this example, the sine of the angle was the cosine of its companion angle, and so was this. So we talk about 90 minus for the opposite. We're started with sine, we're going to change it to cosine. To change it to cosine, I put 90 minus the angle that was given, 61, is then cosine of, and we do the subtraction, and that would be 28 degrees. Now we can prove that they are companion or equivalent sine and cosine. So if I put sine of 61 and enter, and I put cosine of the 28 and enter, I have, 29. Sorry about that. Nobody caught me. I apologize. It should be cosine of 29. I'm going, what? And there it is. They're identical. So, cosine of 29 is equal to the sine of 61. And 61 plus 29 is 90 degrees. So here we have the cosine of 35, and we want it in sine. So I'm going to put my sine, and I'm going to put 90 minus the cosine angle, and do the math. And I'm going to get, it looks like 55. Now we're going to check to see if they are correct. So I'm going to do sine of 55, in case I made another error, you never know, cosine of 35. And they are identical. All right. So now we talk about this group of information. It talks about if we don't know, if we want to know angle size, and we use inverse trig function. We're using, when we do the inverse, the ratio we constructed. All right. So, in other words, if I know tan A BC over AC, then tan inverse with a -1 of BC over AC equals the angle A. All right. So now we're using that concept. So here we go. Solve the right triangle, round decimal to the nearest tenth, 1 decimal place. All right, we don't know very much on this one, but we know this, and we can find this guy. So we need the measure of angle L. We need the hypotenuse, NL, and we need the side, ML. So we need these three things to complete what we have. So let's start with the measure of angle L. Angle L is going to be 90 minus 37, because we're using the corollary. I get, oops, I get 53 degrees. Very good. So I got the L. Now I'm going to get what I have, and I can either do I can do the cosine, or I can do sine. It doesn't matter what I want to use. Let's go with this one next, the hypotenuse. So I have 53 and 37 make 90, so I'm good. I'm going to do the sine of 53 degrees equals the 6 over the hypotenuse. So I'm going to have h sine of 53 equals 6. Therefore, h has to be 6 divided by the sine of 53. So we're going to stick that in our calculator. 6 divided by the sine of 53. And I get in 1 decimal, h equals 7 5/10. So I've got this one. So now I can do the tangent. All right, the tangent is opposite over adjacent, right? So I can do the tan of 37 equals the, we don't know it, the ML, which is opposite, over adjacent, which is 6. 6 tan of 37 equals that length. I'm going to put it in. I get 4.5. So now I have all three conditions and I've solved the right triangle. I have one more with two sides given. So this one we are going to use to get xy. We're going to use Pythagorean theorem. So I have a hypotenuse. So I'm going to have 18 squared plus xy, that's the line squared segment, equals 25 squared. So I'm going to have xy squared equals 25 squared minus the 18 squared. So let's do that math first. Okay, we're looking good. So I'm going to hit enter and I get 301. So I'm going to take the square root. So the line segment xy is the square root of 301. 17, and we said, I think it said tenths, right? Yeah. So one decimal. And that'll make it 17 and 4/10. So that gave us our side. Okay. Now they want our angles, right? So if I wanted this angle right here, x, I have opposite over hypotenuse. So that's sine. Sine of angle x equals 18 over 25. So now I'm going to do sine inverse of 18 over 25 to get the measure of angle x. And we're going to stick that in the calculator. To get an inverse, you do the second of whatever trig function we are looking. So you'll see the little -1 up there. And then I'm going to enter 18 divided by the 25. And I'm going to do one decimal, 46 and 1/10 degree is the measure of angle x. Okay, so I got that one. Well, now I need angle z. Angle z is, I have a cosine, right? Look, I can have adjacent over hypotenuse. So I'm going to do cosine of angle z 18 over 25. So I'm going to do the inverse, cosine inverse of the 18 over 25 is equal to the measure of angle z. I'm going to hit second cosine, and in the parentheses I'm going to enter 18 divided by the 25, and I get 43 and 9/10 degrees equals angle z. All right, we're doing very well. All right, you can see there's so much in the trig one that it was important that we spend this time and make sure we understand it. Now, if we're given an enclosed angle and two sides, we can calculate area. Area is little formula, 1/2 the two sides multiplied by the sine of whatever the enclosed angle is. So right here we have the enclosed angle is B, and we have little a and little c, the sides around it. So we want the area. Just put that in the calculator. I put in everything right. So my area is 41, and it didn't tell us how many places. But on this one, I'm going to do 4. I mean 2. Sorry about that. It is a 4. Square units, because area is in square units. Very careful. Here we have the 2 sides and the enclosed, 2 sides and an enclosed angle. So our area is 1/2 of the 13 times the 7 times the sine of 68 degrees. We're going to enter that in the calculator just the way we see it. Here, I've got it in. And I'm going to have area is equal to 42 and it looks like 1900 square units. Area is in square units. Very good. Now we're in the last 2 things of consideration. And this is the most math. You won't have both. You'll only have one. And the sine one is really the easiest, so I'm going to probably have that. The sine are ratios of measurement over the sine of its angle. And it's equivalent for every companion. And you can find either the angle or the size of the side. The law of cosine is a little more mathematics. And it has the angle, and the opposite side of that angle is what you're solving for. And it's equal to the square of the other 2 sides added minus twice their product plus the cosine of that angle. So let's look at this one right here. So I'm going to draw it, and remember it's not to scale, but it gives us an idea of what they're saying. Angle B is 98 degrees, so it's obtuse. Side A is 12, and it's always opposite the angle A, and B is 21. So we have the opposite side of the angle, so we're going to use the law of sines. And I'm going to state that I have 21 is to the sine of 98 degrees as 12 is to sine of angle A. Now, notice I didn't put inverse anything yet because we haven't done the math. So we first have to do the construction of what we're talking about before we do the inverse. So I'm going to cross multiply. Always put the number in front of the trig function. Now I'm going to divide by the 21. And now I'm going to do the inverse of it, so that the measure of angle A is going to be sine inverse of that. And we're just going to put it all in the calculator. All right, here we go. We're going to go first, let me clear it, second sine. Now sine inverse is up there, and I'm going to put 12 sine of 98, okay, and close parenthesis, because I have to make sure the argument is complete, divided by 21, and close parenthesis again. This one for the small one and the other one for the large one. Here we go. And so the measure of angle A is 34 5/10 degrees. So we got A. All right. So now what we can do is say 180 minus 98 minus 34.5 will equal the measure of angle C. So I'm going to do that in my calculator. I get 47.5 degrees for angle C. So I've got the angles. Now I need one more side. So I always start with what was given, which was 21 is to sine of 98 as, and I'm needing C, little c over sine of 47.5. Does everybody see that? So I'm going to multiply by sine of 47.5 has to equal C. And that's just a matter of putting it in the calculator. 21 sine of 47.5, close parentheses so that you'll know that argument is done, divided by sine of 98. And then we'll close there too. And we hit enter. So we get approximately 15 6/10 is the C, and we're done. That concludes what I want to cover. I'm not going to do cosine. You'll do that in Algebra 2. But all I did in this course is get you exposure. And we've done a very good job. Okay, class, now tomorrow on Thursday, you'll have your worksheet on this trig information. Be sure to have taken notes so that you can properly execute the practice. Remember, it's your final. Thank you for listening. Be polite to one another.